You know, when you see a honeybee buzzing around, it's so easy to just think it's wandering from flower to flower. But what's really going on is, well, it's way more intense than that. Every single flight is a high-stakes mission, a series of incredibly complex calculations that the entire hive's survival depends on. So let's get into the absolutely fascinating world of the honeybee forager.
All right, so here's the game plan. We're going to break this down into 4 parts. First, we'll meet the forager and figure out what her job really is. Then we'll talk about the economics of nectar. Yeah, economics. After that, we'll look at all the other stuff they have to collect. And finally, we'll cover the ultimate challenge. What happens when their entire home gets moved?
Okay, so first things first. Let's meet the star of our show, the forager bee. And you've got to understand, this isn't just any bee. She is a seasoned veteran, a specialist who takes on one of the most dangerous and vital jobs for her colony.
Yeah, this is not an entry-level position. A worker bee actually spends the first 3 weeks of her life working inside the hive, doing all sorts of jobs. It's only after about 21 days that she finally gets her wings, so to speak, and graduates to the role of forager. She's paid her dues and is ready for the outside world.
And what is her mission exactly? Well, it's called foraging, and it's all about flying out to gather 4 things that are absolutely critical for the hive to survive. You've got nectar for energy, pollen for protein, water to keep things cool, and something called propolis for basically construction and home defense.
What's really cool is how they get ready for this. Before she goes on these long-haul flights, a new forager takes these short, circular orientation flights right around the hive. She's literally building a mental map, memorizing her home's exact location down to the centimeter. Only then does she start the real missions, which are amazing because they're based on what the hive needs right now. The colony basically sends out a memo. Hey, we're low on pollen, and the foragers respond.
Okay, let's talk about the cargo everyone knows about, nectar. This is the hive's jet fuel, its main source of energy. But collecting it isn't just about finding flowers. It's a masterclass in cost-benefit analysis. A single forager bee is a ridiculously good athlete. I mean, if she absolutely has to, she can fly up to 7 kilometers for a nectar source. That's over 4 miles, an incredible range for such a tiny creature. But when you hear that number, you have to ask the obvious question, right? When your whole job is to bring fuel back home, does it really make sense to fly as far as you possibly can to get it? And that is the problem. It's the ultimate catch-22. A bee runs on nectar. So if she flies a really, really long way, she ends up burning through most or sometimes all of the nectar she just collected just to get back home. The whole trip becomes a waste of time, a net loss for the hive's pantry. And this brings us to the really smart part. While a bee can fly 7 kilometers, the sweet spot, the most profitable distance for a nectar run, is actually much, much closer, around 800 meters, about half a mile. Inside that zone, the energy she brings back is way more than the energy she spent. It's all about working smarter, not harder.
Right, but nectar is only one item on the hive's shopping list. They also need protein for the babies, AC for the summer, and caulk to seal up the house. So let's look at the other critical missions.
And this is where the math totally changes. Check this out. For pollen, that's the protein to feed the larvae, bees will fly that full 7 kilometers, or even more if they're desperate. For water, which they use to cool the hive, they'll go up to 2 kilometers. And for propolis, that sticky hive sealant, they'll go as far as they need to. For these resources, the energy cost of the flight is worth it because the item is just that valuable.
The propolis mission is just wild. They usually get it by scraping sticky resins off of plants. But here's the kicker. If they can't find any, their resourcefulness is just off the charts. They've been seen collecting bits of old paint, asphalt from the road, and even flying to old abandoned hives to recycle the propolis from there. No way they're coming home empty-handed.
So, we've established that these foragers have this amazing internal GPS, right? They know exactly where home is. But what happens if a beekeeper just picks up the entire hive and moves it somewhere else? Well, that's when things get really interesting.
How you handle this all depends on distance. If you move a hive just a little bit, say less than 3 kilometers, the forager's great memory actually becomes a huge problem. They fly out, do their thing, and then fly back to the empty patch of grass where their house used to be. So beekeepers have a clever trick. They stuff grass in the entrance. It forces the bees to stop and shoo their way out, which makes them realize, hey, something's different, and triggers them to do new orientation flights, effectively resetting their GPS. But if you move the hive a long way, more than 3 kilometers, the old spot is just too far away. They can't find it.
and they just naturally reorient to the new location.
So if you put all of this together, what do you get? You see that a forager bee's flight is never just a simple trip. Every single time she leaves the hive, she's running this incredibly complex calculation in her tiny brain, balancing what the hive needs, how far she has to go, and how much energy it's all going to cost. It's an amazing, dynamic system of resource management.
And that kind of leaves us with one last big idea to think about. If a single tiny bee is capable of running this kind of sophisticated cost-benefit analysis for every trip she takes, what does that tell you about the collective intelligence of the entire hive? I mean, what kind of brilliant superorganism emerges when you have tens of thousands of individuals all following these simple yet incredibly smart rules? It's pretty mind-blowing.